Okay. So thanks to be here. We are really glad to be here. Arnaud and I we are glad to host this workshop. So before presenting OKP4, let me introduce myself. So I'm Anthony. I'm DevRel engineer for OKP4. I'm here to help developers to build on the OKP4 blockchain. And I'm like an interface between you and the druids you see over there, the technical team. And one of the druids, the blockchain architect, he's here.
Yeah, so hi everyone, I'm Arnaud Mimart, blockchain architect, and I'm here to help you understand what we are doing at OKP4, guys. Maybe just a word about this outfit. You may know that we have a builders program and a testnet program that are incentivized, and which is called the Nebular program. And the Nebular program is based around the storytelling, around the Celtic universe, and the Nebular is the place where the druids come to share their knowledge. So I am here as a druid to share my knowledge with you. I'll let you introduce the presentation.
Yeah, before practicing, thanks.
Thank you.
So before practicing, we'll give you some the main keys of understanding the main ingredients of OKP4 Potion. So first, we'll give you all the main principles why we are building the OKP4 blockchain. We'll talk about stuff like Prolog, like RDF triples, and then we'll see how we can combine all this together. As Arnaud said, we value the builder community. Yeah, we have a builders program, so here, you're here to learn, and after you will practicing, you will follow the tutorials, and then we'll be able to complete the challenges on the builders program, and we will grant you if you bring valuable contributions. So here, we are here to learn, and we show you the link to the Nebular program at the end of the workshop, so stay here until the end. So now let's talk about OKP4, why we are building this protocol. We can start by oracles. I'm really sure you know about oracles. I mean, Chainlink or Bond Protocol are the most famous one. You know, it's solutions to bring off-chain data to a blockchain context, to smart contracts. So smart contracts rely on oracles to execute transactions. But what if we think about the reverse? What if we have an off-chain world relying only on the blockchain activity for this activity, for these services? That's what we are building with OKP4. So we are thinking about data, but we can also imagine like any services, any algorithm to be shared between several parties relying only on the blockchain. So let me explain you the basic process, and after we'll go into the detail before the end of the presentation. So first, as a provider, you want to share data with other person. So you want to define, you want to reference your resources like dataset or like an algorithm, and you want to define the rules. You say, okay, I authorize to access to my data, but you have to respect this access condition, and you have to share this part of revenue. I have to get this % of revenue. Then a consumer is interested in your resources, wants to consume your services or want to consume your data. The consumer has to request on the blockchain, and the blockchain will validate the request or not. And if the request is validated, so your services will trigger from the blockchain activity to respond back to the consumer to respond to the request. And then your services have to report its status, report its activity to ensure orchestration reliability. I mean to enforce a revenue sharing model. So we have three main pillars, three main magic domain. I'll let Arnaud explain the secret ingredient.
Yeah, so let's give you an overview of the protocol architecture. Basically, the protocol is built around three pillars: the ontology, the governance, and the orchestration. About the ontology, when we talk about orchestrating off-chain resources, we need a mean to describe those resources, and not only describe what they do or what they contains, but also how to invoke them and the communication protocols we need to interact with them. And resources being heterogeneous by essence, we need a semantic layer to make them interoperable. And so that's the ontology. Regarding the governance, when you share resources, you may want to keep the sovereignty about this resource, and you want to create some rules, conditions that needs to be respected in order to share it and to use it. So maybe you want to restrict the usage to some revenue sharing models, to some users, use cases, and that's some rules, and that's in the scope of the governance. And finally, to make the magic happen and to allow to bridge the gap between the on-chain and off-chain worlds, there is the orchestration layer. But for today, we will focus on the ontology and the governance.
So maybe you're wondering, can you give me an example, a concrete example how I can use the OKP4 protocol? So I'm sure you know about ChatGPT, right? But it's a black box. You don't know from which sources the model is trained. So imagine now a new model, and you know for every source to train the model, it's a request on the blockchain. So everyone can see on blockchain from which sources the model is trained for. And when you request the blockchain, when you want to train the model, so you pay a fee, and you share the fee with the providers, with the resource providers. That's what we enable with OKP4 blockchain. So imagine you are a provider, you want to submit your data, and you want to get value from this. So first, you use the ontology, so you reference your data, you reference all the metadata, you give description, you describe what's your data. Then, you define the governance, all the rules, all the access condition rules, all the revenue sharing rules you want to enforce on chain. And then the orchestration, it's when the consumer wants to consume your resources. And all this consume, it's fully on chain. So OKP4 brings a lot of benefits. First benefit is trust. Imagine we have 100 companies want to share all together their data. Nowadays, they have to have a central entity to gather all the data. Now, with our infrastructure, we enable a decentralized resource sharing. So no more trust, no more trusted third party. We have also incentives, so you are incentivized to share your resources, because you can get value from this. And then, because it's open, you can build upon the blockchain, upon the protocol as you want. So we have a lot of composability. So now, you're mastering OKP4 blockchain. You know everything about it. But maybe you may be wondering, okay, all about the rules. How can you define the rules about the resource sharing? That's what we cover next.
Okay, so about the governance and the rules, the principle is simple. When you share a resource, you can attach some rules, and the rules are defined and evaluated on-chain. But it goes a little further. When a consumer wants to use your resources, it will request the execution of a workflow involving multiple resources, and it's the responsibility of the protocol to ensure that all the rules and the conditions are respected before emitting an event, which is an execution order, and then all the resources will have to respond to this order. The power of the protocol relies in the way we can express the rules. We need a way in which we can express any rules, and we need to provide a framework to design those rules. If we provide a rules mechanism through maybe, for example, a smart contract with parameters, this is not sufficient. We need a lot of expressiveness. So for that, we need a language. We need a DSL, a domain-specific language. And instead of creating a new one, we chose to reuse an existing one, which is a logic programming language. This is Prolog, and I let Anthony introduce you to Prolog.
Yeah, all the magic is possible with Prolog, and we haven't used Prolog because it's created in the south of France like OKP4. Prolog is created in Marseille. We are in Toulouse, but yes, it's a really relevant language because you can code, you can express your rules as you're speaking in French or in English. It's not really complicated to learn and to code in Prolog because all is about facts, rules, and query. There is really working Prolog code. I mean, if you want to define that you have a console, you have a board, and you want to define like Alice and Bob are members of the console, you just have to write this in Prolog. So this is facts. Facts is just the truth. You define what is right, what is true. Sorry. So from the facts, you can define rules. So for example, I can define that anyone can query my data only if the person is a member of the console. So here is again a really working Prolog code. So to query can query my data. So a person X can query my data only if X is member of the console. So then you can submit the facts and these rules to Prolog, and then you can evaluate rules. So for example, I can ask Prolog, can query my data Alice? Alice can query my data? Yes, true. Or you can ask who can query my data? Alice and Bob can. So Prolog is really powerful, and our Druid loves games too. And then find out they can play Sudoku with Prolog. It's not really useful in the OKP4 context, but they like it. So
yeah, so this is just to illustrate the power of Prolog. We won't enter the details of this example, but this is to illustrate how relevant Prolog is when it comes to the evaluation of governance rules. This is the Sudoku game code in Prolog, and this is not just the solving algorithm or just the verifying algorithm. This is both. And this is what we call constraint-based programming, because through Prolog, you express the constraints of the Sudoku game through predicates and facts. And so this is the beauty of Prolog. You can, through one simple definition, express the solving and the verifying algorithm. This is why we use it for the governance layer.
So Prolog isn't interpreted natively by Cosmos SDK. So we build a Prolog interpreter as a logic module, as a module.
Yeah. So to explain a little this module, this is a custom Cosmos module. It is not specifically designed for the OKP4 blockchain. So any blockchain, Cosmos-based blockchain, can use it. It basically embeds a Prolog interpreter. And this interpreter, to allow the rules to be built around some context of the resources and so on, we need to be able to import the blockchain state as a context inside the Prolog interpreter. So we created some custom Prolog predicates that allows to communicate with the module state inside the interpreter. This brings some facts database, and we are also able to communicate and interact with smart contracts using a virtual file system that we've built, enabling a querying mechanism. And to go further, designing rules and Prolog programs with the logic module, you may think it can be a great value to share common Prolog programs to be able to enable the composability of Prolog programs instead of duplicating all the Prolog codes. So for that, we developed the Objectarium smart contract, which is a simple object storage smart contract. But the interesting thing is that you can import Prolog code in the logic module from the Objectarium smart contract. So you can have, for example, one main Prolog program which imports multiple other Prolog sources from the Objectarium. The Objectarium also have specific feature, which is a pinning mechanism that allows us to pin objects to prevent them from being removed. And this is used for the availability, because through another smart contract, the Lowstone smart contract, you can instantiate it with a main Prolog programs, and it will track all the Prolog programs used from the Objectarium in order to pin them and make sure that all the rules stay available at all time, so we can rely on it.
So here is an example with OKP4D. So it's a command line interfaces. So it's a binary to interact with the blockchain. So here we can ask to the module directly to evaluate Prolog's rules. Something we haven't said before is our druids build specific predicates to have data from the blockchain context, for the blockchain state. So here is, for example, you can have the balance for a specific OKP4 account. So here, with the predicate bank balance with this OKP4 address, you can ask here in red for the balance, the no balance. No is the token of our app chain. So here is how you can interact with the logic module. So OKP4D query logic ask, you have your query, and the logic module respond with the response. You can also interact with a smart contract, a Lowstone smart contract. So imagine the previous code I show you in the presentation. Imagine we upload it, we instantiate a Lowstone smart contract, and then we can query this smart contract with a WASM contract state smart. Here is the Lowstone smart contract address, and you can query my data X or woo, and we have Alice, and we can also have Bob. So now I'm sure you really want to code your first Prolog program, but wait. We have to explain another thing, another concept. It's how you can reference your resource. So here with Prolog, you know how you can define the rules, but how you can reference your resources. And yes, you know all the main keys of understanding for the protocol. You know how to define the rules to share resources, but now, how can you describe the data set or your algorithm? It's with a knowledge graph. So it's not dark magic, but it's something very powerful. I'll let Arnaud present this.
Yeah, so about the ontology, you can see it as the persistent layer of the protocol. Basically, you can define the resources properties, metadata, the execution history, but it goes a little bit further. The ontology is a formal representation of the concept, the relationships, and the properties of the protocol. Through it, you have a semantic layer that allows to make resources interoperable, and to basically on ontology, you can see it as, through the ontology, you can define both the models and instances you're dealing with, and you can represent it as a knowledge graph, sorry.
So we have multiple ways to express to reference a data set or an algorithm. We have chosen a standard, pretty well-known standard, RDF triples. It's not something created in the south of France, but it's as good as well as Prolog and the blockchain. RDF triples are pretty simple. If you browse in the open data platform, you will find a lot of turtle syntax files or something like that. It's RDF triple. So with RDF triple, you express everything in 3 parts. First part is the subject, the predicate, and the object. So here is a simple example. So let's say you want to define that a data set is provided by a specific services. So you want the subject, a data set A, to express to be provided by a service B. So this is not a really working code. This is a really working code. So here it's link. It's not really access link. It's to define the domain. It's to define like a data set is provided by a specific services. It's not really easy to read, right? So here at OKP4, we like the turtle syntax because you can define prefix to define the domain. And here you have really working code in turtle syntax to define RDF triples. And with this syntax, you can define anything in any way. So here is another example. Let's say like the previous service B here can be also as a subject to define the S3 AWS bucket. So here is how we can define like that the bucket of the service B. So you know, RDF triples cannot be interpreted natively by Cosmos SDK, by a module. So the Druid again built something specifically to interpret and to store and query RDF triples.
Yeah, and that's another smart contract. So we developed the Conitarium smart contract, which is a simple triple store database. So you will store and index triples. You can insert triples through various RDF formats, and then the query API is largely inspired by Sparker endpoints. So if you are familiar with Sparker and RDF, you will be comfortable with the Conitarium. Basically, you can query triples by expressing some constraints with triple patterns.
So here is an example. So imagine the previous order of triples. Imagine we stored it in a Conitarium smart contract with this address. So we can query this smart contract. And imagine we want to get back the services we declared in the RDF triples. So for example, we define this subject, the predicate here provided by, and then the smart contract responds back with our service ID over there in blue. So now you understand why we built OKP4 protocol. It's about decentralized resource sharing. To share the resources, we have to define the rules, and we use a product program. You have to reference the resources, so you use a knowledge graph with a topology using RDF triples. So now, let's combine all this together, and let's detail this schema with all this technical stuff.
Yeah, so this is the same example as earlier. You need to know that when you interact with the protocol, you have a single entry point, but here we will see what's happening under the hood. So when you are a provider and you reference a resource in the protocol, basically there will be some insertion of RDF triple in the Conitarium, and there will be a Lostall instantiation to make the rules. Next, when a consumer wants to request some execution of resources through the protocol will fetch all the context of the resources in the Conitarium and will evaluate the rules linked to those resources to ensure that they are valid and the request is okay with the rules. And basically, it will insert an execution order in the ontology. And then the resources will have to respond to this order, to process themselves, and finally to report their status by inserting some status in the Conitarium. So any revenue sharing mechanism can be applied on it.
So now, congrats, you understand everything. So now you can practice. What we propose you is to follow this first tutorial about Prolog. So what we propose is to create your first main basic Prolog program. You submit the Prolog code to the blockchain, and you try to query the program. Maybe you have to install Go and the CLI, the OKP4 daemon, before. We are here to help. So here is the first tutorial. Then we can propose you another tutorial. It's all about the ontology, and then we'll show you the link to the builders program. So you can try to complete the challenge, and maybe you can get granted with no rewards. At the end of the workshop, we'll show you also a QR code for your cred. It's a proof of attendance for this workshop. So I propose you to scan this QR code and try to express your first rule, the first way to share your services. And we are here to help. We have also other Druid here to help you. So.